Hello. Okay, everyone, let's start. So I know it's a long day, and thank you all for coming. We have a Logic Lounge, and I don't know how many of you have already visited Logic Lounges. So only a handful. So this was the idea that started probably like 10 years ago when Helmut White organized CAV at Vienna. And the idea was, let's not only talk about things that we are doing, but let's also talk about things that are kind of connecting logic, reasoning, formal methods with something else. And let's kind of have this talk open for the whole public. And that's what we kind of will try to resurrect and have Logic Lounges again. So it's my great pleasure to introduce today's speaker. Today's speaker is Professor Scott Shapiro, who is professor at Yale Law School, but he's also professor of philosophy. And just a second. Okay. So Zoom is working. So to tell you a little bit more about Scott, and so his area of research is like legal reasoning, jurisprudence. You probably have heard about his book, Fancy Bear Goes Fishing. Let's see, how many of you have read that book? Okay. Everyone, be like Moshe, okay? He also wrote the book, so several other books like Internationalist, and his area of research is very much related in the legal, but nevertheless, a parallel at the same time, he also has a different life. And that's the life of computer scientist who is involved in security, also in automated reasoning. And today, he will tell us how far and how close we are from realizing Leibniz's dream. So thank you very much, Scott, to find time in your to schedule and giving this talk. Thank you.
Well, hi, everyone. Thanks for coming. It's a formal conference, and at the end of the day, I'm sure everyone's extremely tired. So I'm not gonna set out too many proofs and try to have a good time for this hour. So realizing Leibniz's dream refers to the idea of automating legal reasoning. But in many ways, this has been my dream too. So when I was a grad student, so what happened was I went to law school, and then I did a PhD in philosophy, and a grad student in my year had just come from Italy, where he was working on theorem provers and as applied to legal problems. And I had been interested in trying to formalize legal codes. And we immediately hit it off, and we spent a couple of years doing research on trying to automate legal reasoning. And we published some things, and we did, I think, some mildly interesting stuff. But then we were informed by people in computer science that automated reasoning is not really a thing. By the way, this was 1993, and that it was a dead field. And that aside from theoretical problems of undecidability, there were practical problems about combinatorial explosion, and that really there was never going to be theorem provers that could operate on the scale that we wanted them to. And so I should just stop. And so I did. And about almost 3 years ago, I met Ruzhika. And I said, oh, what do you work on? She said, automated reasoning and formal methods. I said, I thought that was dead. And she assured me that it was very much alive. And then so she started teaching me about resolution and Herbrand models and predicate abstraction and model checking and all these things. And I was like, when did all these things start? And she was like, oh, around like 1994. So this is, for me, is very much like a Rip Van Winkle experience of wanting to do something, going to sleep for 30 years, waking up. And all of you have invented the technology and the algorithms and heuristics that I hope can actually realize Leibniz's dream of automating legal reasoning. And what I'll be doing is, this will be talking about joint research with Ruchika. So, and since she taught me all I know about it, if I make a mistake, it's her fault. Okay. So this is Gottlieb Leibniz. So I'm sure, like, he's a philosopher. He was actually spent most of his time being a historian. He did an enormous amount of work, archival work, collecting diplomatic correspondence and treaties. He was a lawyer, trained as a lawyer. As you probably know, he's one of the fathers of AI. Probably less well known is that he really pioneered the use of logic in law, and also the idea of automating legal reasoning. This is, I'm sure you've seen this quote a bajillion times, given what you do, to take a pen in hand, sit down at the abacus, and having called in a friend, they want to say to each other, let us calculate. So the idea is that you not only just solve scientific or mathematical questions and disputes, but also normative disputes, legal disputes. So that's what he thought might one day be possible. And if he had his way, this would be called abacus-aided verification. I thought that would land better. Okay. Okay. So not only is automating legal reasoning, I think, intellectually exciting, but it has great practical implications. People, when they say that, oh, are you trying to put lawyers out of business? I would say, like, as if the vast majority of Americans have access to legal services. They do not. There are not nearly enough lawyers to handle what people need. So almost 3/4 of low-income households experience at least one legal problem in the past year. Almost 40% claim to encounter 5 or more. Paul Solman estimates that $80 billion a year goes unclaimed in government benefits just because the rules are too complicated. So if there was some way in which we could automate this, we could actually help people who don't have access to legal services right now. But also there's a huge business need. American companies spend 2 to almost 3 times the amount of money on legal services than their global counterparts, in part because the United States is a leader in high-tech industries. High-tech industries tend to be heavily regulated industries. And so the use of this technology has potential to lower costs for U.S. companies as well. You probably have heard of some of these things. There's been a long history of trying to automate legal reasoning. So the earliest versions of this were the kind of classical symbolic AI. In the 1970s, the expert system tax man to help people figure out what their tax liability is. Things became more interesting in the 1980s, where new systems were developed that were vector-based. The most sophisticated hypo had 11-dimensional vectors, which is kind of, I think we say 11-dimensional vectors in the world of large language models. The 1990s, I love this name, Shyster. It's a computer program that used statistics to predict court decisions. Infamously, the use of machine learning as applied to legal tasks such as probation, Compass, which really set off the whole debate about algorithmic fairness. Then in the 2010s, there's an explosion of domain-specific languages and programming languages for law, among the well-known one is Kabbalah. And of course, in the 2020s, there's been the use of LLMs for legal reasoning. And I'm sure we've read about like the problems associated with that, with hallucinations and the like. Okay, so let me just talk about how one way to approach automating legal reasoning. So taking inspiration from formal methods. So the mistake that was made, or maybe not the mistake, but not the most effective way of tackling problems in formal methods was to try to build one theorem prover for all first-order logic or for the decidable fragments of first-order logic. And that's why things weren't getting, that's why my computer science friends thought that it wasn't going to work. And then the breakthrough was to slice things up into theories and start building decision procedures for particular theories, whether they be bit vectors or linear arithmetic, and then stitch them together. And so the idea here would be to focus on particular styles of legal reasoning and legal problems and try to pick the computational techniques that fit those problems the best. So just, now this is going to be a very, very crude cut at legal reasoning. So, you know, basically you could think of legal reasoning as coming down in two styles. One is rule-based reasoning, which is largely deductive, and case-based reasoning, which is largely inductive. And so what I'll be arguing is that for the rule-based reasoning, the engine should be of the automated reasoning sort, whereas for case-based reasoning, it should be of the large language model sort. So let me just, because I'm not sure how much I should assume here, let me just talk about what I mean by rule or code-based reasoning versus case-based reasoning. By rule or code-based reasoning, what I mean is you have a domain, which is like, let's say, tax, which is filled with very dense and complex code rules. And you have a fact pattern, and you want to know what the rules require you to do in that fact pattern. And again, that's largely deductive. And what's really amazing is how complex rule-based reasoning can be. We all know from tax can be very complex. This is greenhouse gas emission requirements. You would be extremely surprised how incredibly complex these environmental regulations are. My favorite example for people is the FDA has all these regulations over different kinds of mustard. So there's yellow mustard, jalapeno mustard, Dijon mustard, coarse grain Dijon, honey mustard, stone ground. There's lots of them, but it doesn't have here. This is just one of the tables. This is the titratable acidity, salt content, and total solids. There are many other specifications for what counts as Dijon mustard. You would be, I mean, again, you know, until you start doing this work, you cannot believe how many rules human beings have made. Right, okay. or at least test them all. Okay. So that's what I mean by rule-based reasoning. By case-based reasoning, so like when you see in TV shows, you see law books in the background. They're almost all filled with cases. This is the United States report. They're filled with Supreme Court cases. This is, you know, what the top of the New York Court of Appeals case looks like. Interestingly, a fun fact, the Supreme Court in New York is the lowest level, and the Court of Appeals is the highest level. And so this is a case from the Court of Appeals. And a case will generally, this one's I just selected this at random, and then I decided to look at it, and it turns out to be habeas corpus relief on behalf of Happy, an elephant residing at the Bronx Zoo, in order to secure her transfer to an elephant sanctuary. I'm sad to say Happy lost this case, but what you see here is that the case will itself cite many cases. And so in a case-based aspect of legal reasoning, you have tons and tons of cases. And you have to try to figure out what the patterns are in these cases. And the reasoning, again, is not really deductive, although there's obviously deduction there, but more induction and analogical reasoning. So these are ideal typical claims. You know, most legal problems will have mixtures of rule-based and case-based, but I'm just taking them as ideal types for now. Okay, so for the idea is that to create two different kinds of systems for dealing, one for dealing with rule-based legal reasoning, the other one dealing with case-based legal reasoning. So the first one we call code bots, and they're used for densely specified law like environmental regulations, tax provisions, and of course, mustard regulation. And we'll show how those are constructed. And then case bots, which operate in the common law case-based universe, and the LLMs will be doing most of the reasoning. Okay, so what's the architecture of a code bot? So you start with laws, regulations, policies, whatever in natural language. So to say English, and give a precise specification in formal logic. We now use just plain old first order logic, and the translation is done by customized LLMs. Then what we do is we take the formal spec and turn it into a decision tree using SMT solver. We use Z3, and then take the decision tree and through parsing of the decision tree, create a GUI front end. Now, the reason why we create a decision tree is because what we want is for the user to be able to use the tool without knowing what the rules are. See, the thing is, if you don't guide the user through the workflow, they would have to know what the normatively relevant variables are, but they may not know it. So the idea of the tool is to present the user with what are the normatively relevant factors, have them answer questions, and then based on their answers, optimize the next set of questions so they're only answering the questions that they need to. So let me give you an example. So the first application involved Yale human resources. So we went to human resources and we said, what's your pain point? And they said, well, our pain point is that we, at Yale Law School, we have these fellows. And as you can imagine, we have like a million different kinds of fellows with a million different kind of rules that specify who can be a postdoctoral associate as opposed to who can be a research associate, who can be a senior research associate, who can be a research scientist. There are all these categories. And the law school hires 120 each year, which means is that at least 120 emails get sent to HR saying, how do I hire this person? Like what category do they fall into? What are the requirements? So what HR did was they took all the rules and they put it on a web page and created a really involved FAQ, and nobody has ever used it. And so what she wanted, Karen Alderman, the head of HR, what she wanted was some tool that guided people through the process of hiring without having to know what the rules are. So this is one of the rules that we formalized. There's many, many rules that we had to formalize. The rules of Yale University are online. They're 300 pages, single-spaced. There are lots and lots of rules, and this is just one very small part of it. So you took this, and for us, this is just converted into SMT-lib, and then create the decision tree. And again, it's optimized so that the user is sent down the shortest path given their answers, and then finally given the answer. So this is what the tool looks like. We call it Alfred because what Karen says, she wanted a hiring concierge, which we should love that, the concierge. And so like Alfred's a concierge. Okay, so you put in, you want to find the right fellow category for new hires at Yale Law School, and where the users, they are faculty and staff. And so what you could do is you take the policies, upload them as a PDF, and it will generate a GUI. And then when a faculty assistant or professor wants to hire somebody, they go to the app. The app will start asking them questions. Will the fellowship be paid or unpaid? Paid. From which funds will the fellow be paid? Grants, yada, yada, yada. And then it turns out that it's a postdoctoral associate. If you had chosen different answers, you might get different questions. One of the great things, as everyone here, I'm sure knows, is that solvers are explainable. So one of the things that we do is we give the user a proof if they want it and the sources for why they got the result that they got, because it may turn out that they can't hire a specific fellow and they will then freak out and call Karen. But what we're trying to do is trying to show them where in the workflow things went wrong so that first of all, they don't get mad at HR, but also that they could probably go either fix it or lie when they're answering their questions. I am a lawyer, so, okay. So one of the great advantages of using automated reasoning for rule-based reasoning is that you don't get this problem that people get with LLM-based chatbots. So much compliance nowadays is done with LLMs and chatbots. And so you can get a situation where, like, let's say you're a claims adjuster, and you're like, I'm processing a flood insurance claim. The customer is asking for their art object to be reimbursed. Their policy is a national flood insurance program, which is run by FEMA, and they'd be reimbursed. And then the chatbot gives you like a really great answer. It does provide coverage, but there may be specific limits. You should check it out. And then a few days later, it says, no, actually you can't. Those are excluded. And then lately courts have been holding companies liable for the hallucinations of their chatbots. Now this, I won't spend much time on this because it'll be, I imagine it'll be obvious to everyone here, but if you're going to use automated reasoning and solvers for compliance checking, you're not going to get that situation. You're with a given set of encodings, you're going to get the same answer each time, and you're going to get the same sources each time. And that's because even though the user sees, only the tool, it's from behind the scenes, since everything is being converted into first-order logic, not only the responses, but pre-processed codes being converted to formal logic. And those formula all being piped to a solver. The solver will, of course, say SAT or unsat, which won't be particularly helpful to the user. So you pipe that again to an LLM that can translate for the user in some kind of friendly way. You're going to get the same answer each time. Okay, so Rushka and I taught a course called Law, Security, and Logic. I think this was when we did the proposal, I'd say, I think it was the fall of 2022. And we went through the whole shebang, you know, like propositional logic, first order logic, SAT solvers, SMT solvers, synthesis, you know, talked about different forms of legal reasoning, explained all this stuff because we wanted them to, as their final project, to create a tool for FISA. Now, for those who may not know, so FISA is the main authority in the United States, the Foreign Intelligence Surveillance Act, for surveilling in the United States for foreign intelligence information. This is the famous, like, Snowden warrantless surveillance program of Bush and Obama, that what they were doing was they were not following FISA, okay? And the main provision of FISA is 50 US Code 1801F, okay? That is the main provision. F defines what is electronic surveillance. Now, one of the things that what's bizarre, and you know, I'm sure from good code writing, is you're never supposed to put like substantive stuff in the definition section. The FISA was written to obfuscate the actual legal requirements. It is incredibly difficult to understand. That is, if you try to sit down and formalize it, it took me 5 hours to do. It's so complicated and so confusing, even though it's very short. Okay, and it was written to be super confusing. And then the students took it, and based on all the stuff, they hand coded it and they built a GUI. And so it took the whole semester to get the tool that we have now does this automatically in 5 seconds. So what we did was we kind of created this course and kind of like had to teach the students and ourselves how to do it, and then built a tool to automatically do it. And so there are two things you can use this tool for. One is compliance. You can add, you can be in the FBI and you can say, do we need a FISA warrant? Is this electronic surveillance? But you can also flip it around. You can use it for exploitation. You can say, we don't want to have a FISA warrant. How do I do it? So in one case, you want to know the value of a variable. The other one is you say, this is the value of the variable. How do I get there? And so whether you want to use it for compliance or exploitation is up to you. It's the same basic pipeline. Okay, what are the complications? Non-monotonicity. As we all know, first order logic, classical logic is monotonic, but the law often exhibits, as so much of common sense reasoning, non-monotonicity. So you can have a rule that says if a person is an employee of a company, they're entitled to benefits under its health insurance plan. Alice is an employee of company X, so you conclude Alice is entitled to benefits under their health insurance plan. And then there's a rule later on that says anyone employed by a company on a temporary contract is not entitled to benefits under its health insurance plan. And it turns out Alice is employed under the temporary contract, under a temporary contract. And then it would seem that you get non-monotonicity, that the conclusion flips. So how do you deal with that? Analogously, inconsistency. Every legal code is bound to be inconsistent. It's just bound to be. And so how do you deal with that? Well, one thing I just wanted to point out is, if you remember Bush versus Gore was based on an inconsistency in Florida law. And the Florida Supreme Court and then the United States Supreme Court was called into how do you resolve this inconsistency? what I think you need to do if you're dealing with a huge legal code is you're going to have to ignore global inconsistencies and focus on local consistencies. That's one way to do it. So that is, if there's an inconsistency that doesn't affect your inference, then you should kind of screen that off. Or you can fork. You can fork the model and say, well, here's one consistent code, here's another consistent code. The tool can't decide. Okay, open texture. So policies are formulated in natural language. Natural language is unlike formal language in the sense that it often has vagueness and ambiguity. Given that, formal methods are going to break because you won't have well-defined extensions on your predicates. So let's say you have no vehicles in the park. What about electric scooters? Are they vehicles? Ambulances, are they vehicles? Golf carts, are they vehicles? These are all old problems in legal philosophy, but they, like, well, if you're going to build a tool, you have to figure out how to deal with them. Okay, statutory interpretation. Okay, let's say the policy says no vehicles in the park. So if what we, the first interpretation is, you know, for all X, if X is a vehicle, then X is not permitted in the park. But in fact, that's not the way lawyers would actually, or regular people would interpret no vehicles in the park. I actually almost said lawyers or humans. So no vehicles in the park, they would probably interpret it with a biconditional. They would probably say, well, it says no vehicles in the park, but all non-vehicles are permitted in the park. And this, in Latin, this is expressio unius est exclusio altaris, if the expression of one is the exclusion of the other. So not only do you have to worry about syntax and semantics, but you have to worry about pragmatics as well in terms of interpretation. So this is not like you just throw code at an LLM and hope for the best. I mean, these are problems that have to be worked out. I think that they're really interesting. I like to call this computational jurisprudence. That is, I think we're entering an age, you know, so I was here for the lean talk earlier, where we was talking about how, you know, people can't understand some of the proofs. Well, that becomes trickier when you deal with law. Like, what happens when there are computer-aided pattern recognition that humans can't identify? What do we do with that? There are just more technical questions, which is, do we need deontic logic for dealing with legal codes? Do we need non-monotonic logic, or can the monotonicity of first order logic be good enough? How do we scale when we're dealing with, if we're treating all these policies as axioms, and these policies range into the tens, hundreds of thousands? How do we deal with solving on such a large scale? And like I said before, I think that there are really interesting rule of law problems. Okay, that was rule-based reasoning. I want to now move over to case-based reasoning, which really requires a very, very different approach than the code bots. And here we call these case bots, and they can reason about case law. So let me tell you how we do it. What we do is we take an open source model. We started with Mistral 7 billion, moved up to Llama 2, 70 billion. Now we're on Llama 3, 70 billion. And this weekend I will get to Llama 3.1, 405 billion. So the open source LLMs are getting better and better. And what we do is we train the base model on legal principles. And I'll explain why we do this in a second. But basically, what we're trying to do is give the LLM a model of the law in question. And then what we do is we take the secondary model that's been trained to reason about particular domain that we want the case spot to deal with. And then we train it on legal memos and recent cases. Let me explain how we did this in practice. So one of the things that I did 7 years ago is I started this legal clinic at Yale Law School. It's called the Doc Project. What we do is we provide legal representation for independent documentary filmmakers because they don't have like any legal representation. So we provide it. And we have now 7 years worth of work product, memos and briefs and letters and stuff like that are sitting on our shared drive. And every semester, we sit around, somebody presents a client's case, and we're like, didn't somebody work on that before? And like, we're like, look around, we can't find the memo. And so, wait, what if we just took all this work product and trained an open source model on it, and that way we could recycle the information so that we don't have to keep on redoing our work. But the thought was that wasn't going to be sufficient. Imagine I was trying to explain to you New York privacy law. Very intricate stuff about when something is an invasion of privacy. If I explained to you some complicated thing about New York privacy law, it's unlikely that you would retain that much. But what if I took 2 hours out and I was like, I'm going to explain to you media law and how privacy law works. And forget New York, I'm just going to explain how it works, okay, in general. And then, okay, at the end of 2 hours, I was like, okay, now let me explain something very specific about New York law. You'd probably be able to retain and understand it better. And so that's what we tried to do with these LLMs. That is, we tried to basically take it to law school for a particular domain and then train it on the work product from our clinic. So here, what we did is we had the students draw up basic prompt completion pairs. You know, what are the 4 privacy torts? The 4 privacy torts are intrusion upon seclusion, blah, blah, blah. So, you know, give it a very basic hypothetical as a prompt. Give the answer. Can a deceased person's estate bring a suit pleading one of the 4 privacy torts? So that we gave them students wrote these, and then we trained the open source model on that to create the secondary model. And then we have about 100 memos. You know, these memos are long and they've been vetted by multiple attorneys. They're very high quality. And then we train the secondary model on the work product. And this is the tool that we got, that we created, that uses these models that were generated. So it's like a chatbot. You ask it a question, you can ask it very, very complex questions. The question I asked it here was, David is a photographer, and he takes a picture from his apartment building, from his window across the street, of a family in an apartment across the way. And he uses pictures of their children in his art exhibition as a commentary on the anonymity of social life. The family finds out about this, sues David. You're the lawyer for David. What's David's best argument against this suit? Now, it gives you a basic answer to it. And then if you like it, you can ask it to generate a brief. And so this one was generated a week and a half ago, 3,000 word answer. Like, it is I will just tell you, I've shown this to multiple media attorneys. It is kind of shocking how comprehensive it is. It will consider opposing arguments and rebut them, and give a conclusion. So the idea of the case spot is to again kind of mine the formal methods idea of like, don't try to create like a chat GPT for all of law. Try to create one for media law, or maybe create one for documentary filmmakers, and try to not only teach it, give it a model of the law, but then train it on highly curated, but really high quality legal material in that domain. And so far, you know, I think it's, you know, we're getting kind of good results. Let me just finish by talking a bit more speculatively and philosophically about the approach here, which is that I said that when we deal with rule-based reasoning, you can use solvers for the reasoning engine. But it doesn't make sense to do that for case-based reasoning. There, the engines, the reasoning engines are large language models that have been trained in a certain way. Now, the question becomes, will we ever get to the point where we can take all the case-based stuff and formalize it so that we can run solvers on them? That is there a way of kind of unifying all of the automation of legal reasoning so that everything is amenable to code bots, that we don't need this other thing, these case bots? And I want to suggest the answer is no, that we'll always have these two styles of legal reasoning, because this is not an issue just of legal reasoning, but I think of human reason in general. So what do I mean by that? Let me just talk about, so I said like rule-based reasoning, a domain where you have rule-based reasoning is environmental law. And let's say constitutional law is a classic example of case-based legal reasoning. If you look at environmental law, you see it's got dense rules, precise concepts, high logical complexity with low moral complexity. Whereas when you think of constitutional law, you get sparse rules, vague concepts, high moral complexity, but low logical complexity. And I don't think this is a mistake, that is, or a coincidence. Because let me put it in your terminology. It's all about the spec. In environmental law, we can give a really clear spec of what we want. That is, we want this amount of particulates in the atmosphere. Okay, you told me that's your spec. I can create a set of rules, a specific algorithm to achieve that specification. But constitutional law lacks that kind of clear specification. There, we're in the domain of incomplete specification. So take due process. What the hell is due process? It lacks a clear spec. We know certain things violate due process, but we would be hard pressed to state very clearly what it is that is, what kinds of process are due and which ones are not due. And when you have incomplete specifications, you're almost forced to engage in case-by-case regulation, because all we kind of know is in particular instances, that's due process, that's not due process. And then there's going to be, you know, tricky things in the middle. The reason why you have common law reasoning and case-based reasoning is because what you're trying to do is you're trying to muddle your way through decision-making when you have incomplete specifications. And when you have algorithms for incomplete specifications, it's difficult to verify them. Let me give you an analogy. So if you wanted to sort numbers, we have a really clear spec. So you know that all the numbers have to be in ascending order, and all the things in the sorted list have to be an element of the original list. Whereas when it comes to image recognition, what's a cat? Like, what's a cat? Like, you would be extremely hard pressed to say a cat is something that has, you know, a tail and whiskers and fur. And then you say, well, what about a top hat? Well, yes, maybe no. You know, you'd have a really hard time giving a spec. So what we're forced to do is we're forced to use kind of connectionist computational engines like neural nets and do it case by case so as to answer questions that are hard for us to specify. So ultimately, I think that there's going to be a limit to formalization, not just in practical reasoning like law, but also in theoretical reasoning as well. When you have a complete specification, then you can use symbolic AI or automated reasoning and get explainable and verifiable results. When you have incomplete specs, you may be forced to engage in kind of connectionist modes of artificial intelligence, like neural nets, and you'll get results which are difficult to explain and verify. The moral of the story is if we don't know what we want, there's a limit to the precision of our solutions and therefore to the explainability and verifiability. The only way we're going to be able to formalize all of law is if we get really clear about what due process is, what equality is, what cruel and unusual punishment is, and that is unlikely to happen. That's the human condition. Thank you.
There are plenty of hands, so maybe you can go after.
This was a fantastic overview, but I argue that you'll need to combine these two modes. Because even when you do this analogical reasoning, you are saying this is more severe than that. So what's applied there must apply here. Well, now this was implication. This is logic, okay? Yeah. So and part of the problem today, what we know about LLMs, they're terrible at doing very simple reasoning.
No.
So we'll have to find a way to combine the two modes of reasoning.
No, absolutely. That's why I was, first of all, that's why I said ideal, typical. And what I think is particularly interesting, what we're experimenting is connecting the two together, connecting the code bots and the case bots together, because yeah, that's inevitable, I agree.
So I over here next to Moshe, down here. So thank you for a fantastic talk. And just to piggyback on the point made by Moshe, you did mention this, that even when you're doing analogical reasoning or case-based reasoning, there are components that are deductive. And those can be checked through some kind of automated reasoning. And feedback can be provided to the LLMs as a consequence.
Yeah, so I mean,
It cannot be the case that it is free of deduction.
Yeah. So you can definitely I mean, again, there are people experimenting with this right now. So you take the outputs, you formalize the outputs, and you see if the one thing follows from the next, right? So that would be like a kind of a way of verifying that the LLM hasn't made any deductive mistakes. Yeah. But the problem, absolutely.
There's a quick follow-up. So how did you test the accuracy of your LLMs when you went from the informal to the formal? In one of your slides, you were mentioning that.
So I mean,
how did you create the data set? Maybe that's
sorry.
How did you create the data set to train the models to go from informal to formal? There was a slide where you showed you were going from informal language.
Are we talking about the code bots?
Yeah.
Oh yeah. So what we do is, so we first start zero shot using like GPT-4, and then what we do is we start fixing it and adding shots, and it quickly gets really good. But then there's all these various validation techniques that we use to check it. And so that's why I didn't say this is not it's not hallucination free, because the LLM in the translation and it does invent predicates, but we check for new predicates, and we check for things like that. So.
I think I'm next. I wanted to say I absolutely loved your talk, and so did my best friend who I looped in, who happens to be a federal judge. So we've been talking about your work, and she sent me a question for you that I think would be fascinating too. So she said that if you think FISA is bad, have you considered running your same tool on Title 38 of the US Code on veterans benefits, because it is significantly more purposefully obtuse. She said something more obscene than that, but that's, and she would love to see you guys teach the class with Title 38.
Oh yeah, so can I just say, first of all, thank you, Your Honor. So that is one of the projects that we are working on right now. We just actually submitted the proposal for this, to use this technology to help people figure out government benefits. Because I look at it, and it was really created. It really feels like it was created so that people couldn't figure out how they could collect their benefits, and like the hope is that this will enable people to that this will democratize legal information for people who are the least able to get help in the context. We have huge Ruchika doesn't. I have huge problems dealing with this because I'm a lawyer, and I have to make sure to always say that I democratize legal information, not legal services, because that's illegal. So there are huge issues, ethical issues associated with creating technology like this, because we don't want to say you are entitled to this. What we do say is the deductive consequence of all these assertions is this, because I don't want to get this part.
Thanks also for your talk over here. So in verification, we often see that when we're trying to formalize something, that we find all the flaws, all the inconsistencies in the specification. And so the byproduct of having actually a better specification or better requirements is often very important for people using these tools. So I was wondering, do you think that eventually this will help to create better, dense laws where policymakers will be forced to actually write understandable laws? Do you have these hopes?
Yeah, my thoughts are that will never happen, because there's an entire industry that is devoted to writing laws that are unclear and can be exploited. So it is one of the purposes of lobbyists to create special carve-outs that's hard to tell, helps their client. So number one is that the political economy is such that people don't want that. That is, our leaders do not want that. Number one. Number two is there's a well-known phenomenon in the law where the legislation is written purposely in a vague way or in an inconsistent way, so that if things go well, they can claim credit, and if they don't, they can say they misinterpreted. So I don't have actually I don't think the promise of this technology is making our law better, because I know that there are people whose their job is to make the law worse, and I don't think there's going to change it. I think this can help on not on the production side, but on the consumption side. I think as bad as it is, at least maybe people can have a fighting chance learning what was created.
Okay, I think I'm next down here.
Yeah.
So I think this ties with the previous several questions. There's maybe not implied by you, but I think an assumption here that the rule-based side is in some sense like more interesting from the logical complexity. But my sense is that in real life, a lot of the challenges are not in the logical reasoning, but in the interpretation of how the logic is applied, right? So like when you get those questions of like, was the funding from Yale, right? And it's like, well, it was a joint grant with something, and then you go ask a human, right? Or I ask my tax lawyer, can I deduct this or do I have to capitalize this, right? So that starts becoming case law because someone says, oh, there's an IRS revenue decision from. So is that like low-hanging fruit that you could just pre-process in a little layer here, or is kind of the logical reasoning not the hard part, and it's really all this case law, kind of all this fuzzy interpretation, all this common sense reasoning, that's really the challenge.
Yeah, so I think that, of course, nobody has ever talked about how easy an inference was, okay? And 99.9% of the law is the easy case that nobody ever talks about. We only talk about the things where it's like an interesting situation. So that's why I said one of the complications was open texture, which was not everything is going to be just a matter of logical inference, because not only is there going to be questions of, does this count as a grant, but there's also pragmatic questions about like, did the drafter mean to exclude all this other stuff? So this does not mean that within the domain of rule-based decision-making, you're not going to have these questions. It's just that these questions are going to be a very small fraction as when compared to the case-based. Yeah. I don't think
Okay, I need to press the button. I'm sorry. You said you believe certain parts of law will never be formalized, and therefore you need LLMs and other form of neural networks. This is wrong, but in a trivial way. Your processor is already formalized. Every execution of your LLM is a bunch of machine instructions. I can write down a formula, first order logic formula that completely formalizes this. It's just several 100 million lines of code. So the problem is not formalization, but having simple formula that we can, as humans, understand.
I'm sorry. So just it would be the 700 million lines of what? Oh,
first order logic.
Yeah, no, that's why I was I was distinguishing between, let's say, kind of the symbolic AI approach versus the connectionist. I mean, these are all Turing complete. I mean, obviously there are algorithms. Yeah, I get that. The question is whether you're going to be able to take the problem, formalize it, and then feed it into a SAT solve, into an SMT solver to get the result. We're not going to even be able to figure out what are the premises to put into it. That's the problem. The problem is not the inference. The problem is that we don't even know what premises to put in there in order to make it a valid inference. Is that helpful?
Once it's in the LLM, it's formalized.
This is a specific technical question. So about the code bot. So suppose you have a bunch of rules, and one of the things you'd like to do is see whether they're consistent. And I will use an example from your slide. So a person who's an employee gets a certain benefit, unless they're, and then a second rule says they're a contractor and they don't get the benefit. Now, I think your solution assumes some sort of prioritization where the contractor is an exception to the rule and overrides the original rule that says if they're an employee, they get health insurance. What if you don't, if you've extracted your rules, you don't know the prioritization, and you're trying to find out whether they're consistent. I tried something like this, and I looked up a paper somewhere that I can no longer remember the reference to that identified the same problem. And if you do the obvious thing, which is and together your two rules and see whether there's a model, it'll come back and say, hey, no problem, they're consistent. You just can never have a person who's both an employee and a contractor. Right. And so then that raises some questions about, are we using the wrong logic? Did we formalize it the wrong way? Is it the wrong test for consistency? Do you know the answer to that?
Well, what we do is we'll just add a assertion that there exists. So for any of the, yeah.
Yeah, the problem that if you're just going through the rules, you don't necessarily know that it missed this overlapping case because it said there's no inconsistency.
Well, if you look at the model, right, it'll give you why it's consistent. And you'll be able to see that it's assuming that there's no employee. I think that's what we did. So
it would get a model and discover that that's, my thinking is fuzzy, but okay.
I mean, we had to explicitly claim that there was somebody who fell into those buckets, or else the SAT solver would just simply say there's nobody that falls into that bucket. That was one of the very first problems that we encountered.
Yeah, you were actually talking a lot about like common law. I mean, what about have you an intuition what would change in like other law systems? Like I think it's Roman law it's called or something like that. Or would it be the same approach or would things change significantly? I mean, I don't know much about this, but I was wondering.
Yeah, no. So the basic idea here for other people in the room is that Anglophone legal systems are often called common law legal systems because they are heavily case-based. But on the continent, as derived from Roman law, it's often called a civil law system, where the idea is that everything is supposed to be reduced to rules. So in some sense, when I said, is it possible that we'll be able to formalize law, there's like a whole long legal tradition on the continent of believing that that is the ideal and that is achievable. And so you have, that's why you have the EU regulations that you have. That's why the GDPR looks the way that it does. And that's why constitutional decisions, let's say, in France, look so much different than they do in the United States. So most constitutional decisions in France are like 1 or 2 pages long, whereas in the United States, they're often over 100 pages. And so does that mean that certain legal systems have figured out how to get around this problem of incomplete specification and have been able to formalize everything? Well, there's a lot of work that has been done in comparative law to show that this whole kind of veneer of that really when the French Constitutional Court is engaging in adjudication, it looks like they're engaged in rule-based decision-making. They're really engaged in common law decision-making, by which I mean case-based decision-making, because what happens is before the opinion goes out, memos are traded between judges and their clerks for months ahead of time, and they refer to memos from previous times. So what's happening is that there's this kind of case-based engine with a kind of a thin veneer of rule-based stuff that's plastered on top. And it has to be that way because there are no rules that are going to answer the kinds of questions that constitutional courts are faced with. So, my response is there are legal systems whose outward veneer is one that we're on one side of this divide, whereas in reality, they're doing both. Yes.
Thank you so much for the really inspiring talk. So I wanted to continue on this series of questions on trying to save formal verification role and potential role in case law. One thing I immediately thought about when you talked about this type of reasoning was what the analytic philosophers have called constitutive rules. So the fact that you take some facts and you say, well, when these facts occur, they count as this other fact, and it doesn't really matter whether the facts are vague or not vague. I mean, it's just like some convention of language that you say that this thing counts now as that thing. Of course, it makes more sense when the first thing is concrete and the second thing is more vague. But it could be that both are actually open to interpretation. That's what happens in most cases. So in theory, you could also try to take this case law and extract a set of constitutive rules that would say that when something happens that might be vague or not vague, then this other legal concept can apply, and then you could in theory reuse that to do inference in the future, which of course wouldn't solve the case that the court hasn't seen, and then the LLMs would probably be the kind of the only solution because they try to extrapolate over what is considered common sense or common legal practice. But for all cases where there is a rule that appears applicable, then you could probably do something. Have you thought about something in this direction?
Yeah, because so I think in philosophy, there's a divide between two kinds of rules, often called constitutive and regulative rules. So constitutive rules are rules that constitute the domain in question. So like 3 strikes, you're out. So an out, the rule is that 3 strikes, you're out. So that constitutes what an out is. Whereas regulative is about things about how you act. So you're not supposed to throw the bat or something like that. And so people debate all the time whether this distinction between constitutive and regulative rules is real. Okay. I think that really what's going on is that constitutive rules are just the way in which an object-oriented person would state regulative rules. That regular, it's really like whether you consider something a constitutive rule or a regulative rule, whether you're thinking in an object-oriented or procedural paradigm. So I actually think that they're interdefinable. But I want to just, I feel like I spoke unclearly. I don't think that formal method, my claim is not that formal methods is not useful, even when it comes to case law. And so what I mean to say is that's not going to be doing the main reasoning work. If you check, that's really important. But that's not going to be doing the main reasoning work.
Okay, and the last question.
Thank you for the excellent talk. So developers of programs often have to simplify their programs so that they can pass some checker, like you want your device driver to be certified. But then you also have developers who try to obfuscate their program to, when you're writing malware. So it seems like in the legal reasoning space, the first is probably not going to happen, as you alluded to. People are not going to simplify at all. But you think there's a scenario where some of the technology you're building might be used to obfuscate the laws even further and automatically? And is that already happening?
Yeah, that's a great evil thought. That's right. Like you could hide implications, kind of clauses that you don't see actually interact with other things, but your solver tells you it does. And this is one of the questions that I think is raised when you have computational jurisprudence. So in computational mathematics, how do we deal with proofs that humans can't understand? What happens when we deal with laws where we get inferences that only a computer can see and then human can't see? What does the rule of law require a judge to do in that circumstance? And I think that's a really fascinating question. I think it's a new question that's going to arise when these techniques are applied to the law.
With this, let's thank our speaker once again, please.